Hey guys, welcome once more to our YouTube channel. Always a pleasure to have you here. Today we're looking at Littoral Mock 2023, the mathematics section today, episode 2. Let's dive in. Given that x equals a is an approximation of the root of the equation f of x equals 0, then the tangent of the curve of y equals f of x at x equals a meets the x-axis at... Okay, so this one is an interesting one. So we've demonstrated a graph here. So let's say that this is the line x equals a, all right? So it meets the curve right up here at f of a. Now, we understand that the gradient of the curve at this particular point is equal to the gradient of the tangent of the curve to that point, right? So you notice we're talking about f prime of a there, which is basically the gradient of this line. Now, we can do some maths with that, so we can find f prime of a from basically calculating the slope of this line, okay? So you realize that we have 2 points on the line because this is a point, even though you are just seeing this x1 coordinate. So the y here is 0, and then we have this other point x equals a, y equals f of a, right? So we're taking changing y by changing x, we'll take f of a minus 0 divided by a minus x1, okay? So that's the slope right there. So of course, if we simplify, so we're getting this a minus x1 this way, and then we get f prime of x down, right? So you realize that our x1, which is where the tangent intersects the x-axis, is actually going to be a minus f of a over f prime of x. And so you realize that, okay, so x at the point x equals a is basically f prime of a right there, right? So you notice that our x1 is going to be a minus f of a divided by f prime of a, okay? And so our answer is B right there. The general solution of sine x cosine b is, okay, so guys, we notice that, well, this is very straight to the point. Sine x cosine b means x equals to b, right? B is the principal value there, so we put in the general solution. X equals 180 degrees n plus negative 1 raised to the power n times pv. Now principal value here is b, so our answer there directly is C. Okay, so yeah, that one was easy. The equation of the line passing through the point 1, 0 and perpendicular to the line this is, okay guys, so we need to define the equation of this line, but we have just like the point on the line and then another line that this line is perpendicular to. So of course our equation of our line is y minus y1 equals m into x minus x1. What is y1 and x1? They are just a point on the line, okay? So the coordinates of a point on that line, so we get the x coordinate is 1, y coordinate 0. So plug them in here. So you get y minus 0 equals gradient. And now notice that the gradient is negative 2 over 3. Remember that this our line is perpendicular to this line. If you write this line in the gradient intercept form, you would have y to be equals to 3 over 2 x, okay? And so 3 over 2 is the gradient of this line. But since our line is perpendicular to this line, the product of that gradient has to be equal to negative 1. So the gradient of our line will be negative 1 divided by the gradient of this guy's line, which is negative 2/3, okay? And so when we simplify and rearrange, you notice that our answer there is just A. The value of x for which the matrix A equals that has no inverse is, okay, so the trick here is to look for the determinant of this matrix, okay? So just look for the determinant, all right? When you get the determinant, of course, I hope that you know how to look for the determinant of a matrix, right? So when you get that determinant, so that's it. Get that determinant to be equal to 0, okay? So for A to be invertible, so for A to have no inverse, the determinant of a has to be equal to 0. Okay, so this determinant equals 0. What do we have? We have 2 plus 2x equals 0. So our x there is negative 2 over 3. So this should be the value of x for which this matrix has no inverse. But then we don't have that answer, so the answer there is known. The function f is continuous on the interval. This is closed interval and differentiable in the interval. Open interval, the main value theorem states that there exists a value c, where c lies between a and b, such that, alright, so the first thing candidates are supposed to see here is that f prime of b and f prime of a here are not possible to be found. Why? Because the function is differentiable on an open interval a to b. So it's not differentiable at a, it's not differentiable at b. So f prime of a or f prime of b is impossible to be found, okay? So these b and c are already off. But to really look at the concept of differentiability, it's really just the concept of you finding gradient, changing y, changing x. And so we just really have to correspondingly look for, alright, f prime of c has to be f of b minus f of a over b minus a. That's how I get the gradient, right? So correspondingly, our answer there is b. So we have this equals, alright, so we're looking for that sum. Now notice that they are both sequenced an AP with a equals 1 and d equals 3. Okay, if I add 3 to each previous term, I get the next term. So the sum to the nth term of an arithmetic progression is n over 2 into 2a plus n minus 1 times d. This is a common formula. But now we need to find the n term. The n term of an arithmetic progression is a plus n minus 1 times d. Now, the good thing is we know the last term, 118, all right? So we're going to, so we're going to have a here to be 1, right? Because our a here is clearly 1, plus n minus 1 times d, our d is 3. So let's look for n. So you notice that if we simplify, our n there is 40. So this 118 here is the 40th term, okay? So we'll come back here to find the sum of the terms, right, all the way to the nth term. We'll simply say, all right, so we want to find the sum to the 40th term. So n over 2, 40 over 2 into, all right, I've really taken first plus last term here, which still works, all right? Or you just come back here and you put in what you're supposed to put in, it still works. So the first plus last term, you realize that we have this, and so our s, the sum of first 40 terms, which is basically sum all the way to 118, gives us b as our answer. A vector of 15 units and parallel to a vector this is, alright, so we know the magnitude of the vector is 15 units, it's parallel to this vector, so we can look for the unit vector in this direction, okay? So we're calling that arrow cap. So where arrow cap is a unit vector in the direction of vector A, which is parallel to this vector, right? So they share the same direction. So let's look for that unit vector. How do I look for that unit vector? Simply get the vector divided by the magnitude of this vector. The magnitude of this vector is 3, okay? So we multiply this to the, of course, the magnitude of the vector, we get our vector A, all right? So we know its magnitude. Now we've just looked for its unit vector, so we can now find our vector A. So we multiply these together, you get this, and so our answer there is B. Two variables y and x are connected by the equation that a linear equivalent of this equation is. Okay, so we simply have to just linearize that equation, alright guys? So our y is ab raised to the power x plus 1. So take ln on both sides. Ln y equals ln a plus ln b, or that raised to the power x plus 1. Why? Because it's like ab, okay? So ln of ab is the same as ln of a plus ln of b. Remember that b is raised to this power, so we keep the power there. So you notice we can now say, okay, this is ln y equals ln a plus x plus 1, because we can bring down this power, right, into ln b. Okay, and so you realize that that is already D now. Lin y equals lin A plus x plus 1 lin B. That's already B. But in physics, we can go on and then D, sorry. In physics, we can go on and then really linearize. So we'll expand this. So we have lin y to be equal to lin bx, alright? So this lin b multiplied with this x, so we have lin bx plus lin a, so this is our lin a here, plus lin b times this one gives you this. So this is a constant, this is our slope, this is our y, this versus our x. So here in physics we will do that. Then we can further simplify that. Well, lin a plus lin b is the same as lin ab, right? Yeah, we could still do that. So that's what it would look like in physics. Okay, so let's go on to the next. So the roots of a quadratic equation are, the quadratic equation is, okay, so we can look for the quadratic equation by simply getting the product of roots. So get this guy multiply with this guy. Okay, so you put them down like that, multiply, simplify, you get this, and you have p over n there for product of roots. Sum of roots, sum them up. It's really easy to do, guys. Look at how this guy disappears with this guy. So a sum negative m, so negative m, you have negative 2n. It divides with this 2 down here, so you have negative m on n. So that's the sum of roots. Equation therefore will be x squared minus our sum of roots, right, plus product of roots equals 0. So our equation is nx squared plus mx plus p equals 0. Now, the method 2 you can go about this would be to identify, because this is like a really complex root, but it's really easy because you can identify that this is from the quadratic equation b squared, right, or negative b plus or minus the square root of b squared. So this is a negative b out here. This is b squared here minus 4ac over 2a, right? So you just have to recognize that b is m right there, a is n, and then our c has to be this p here. And so, yeah, the parametric equation of a curve are this and that. The Cartesian equation of this curve is, okay guys, so x equals to cos theta plus 1, right? Which implies that, well, let's make cos theta alone on one side. So we have x minus 1 equals cos theta. So y equals 2 sine theta. So let's make sine theta alone on one side. So we have 1 over 2 here to be sine theta. When we square two equations and add, cos squared will add up with sine squared, x minus 1 all squared will add up with y over 2 all that squared. So you have this down here. So you realize how we simplify. We have x minus 1 all squared plus y squared over 4 equals 1. And our answer is D. Given that y equals this, dy dx, okay, let's look for dy dx here. So the method 1 is just like, this is a quotient, right? So use the quotient rule, which is really long. So dy dx is bottom the top minus top the bottom, right? So minus top the bottom here over bottom squared. Yeah, so you just have to follow through with that, and then you get negative 8x over this. But a simpler way to go about it, which is just seen a simpler way to go about it, would be to recognize that this is 1 over this, so we can use indices to write that this is x squared plus 3 raised to the negative 4. And so you notice that, well, you can just use the power rule of differentiation here. So this negative 4 comes down, all right, we subtract 1 from the power, which makes it negative 5, right? Then we differentiate the inner function, right? So we have this as a differential, good, which again simplifies to give us C as the answer. The table above shows the values of x and the corresponding values of y for a certain approximation using the trapezium rule and approximate. Okay, trapezium rule. So h is b minus a over n minus 1, right? So we get b is 4 here, which is like the upper bound, minus for x, minus the lower bound for x, which is 0, divided by the number of ordinates, minus 1. So how many ordinates do we have? 1, 2, 3, 4, 5. So we have 5 ordinates. Subtract 1 from that. So you get the number of strips. So you get that h is 1, which is basically a step length. Again, you can still get this step length h without doing all this calculation. Like I'm just showing you how do we get h. So you notice that x here is 0, 1, 2, 3, 4, 5. So notice that the common difference here is just 1. So that automatically becomes your your step length. Okay, so it's 1. So trapezium rule means that if I'm integrating from 0 to 4 of y with respect to x, we'll simply have h over 2 there into the n's. So y0 plus yn plus 2 times the rest. Okay, so that integral is half. What are the n's? 0.3 and 2. So bring those two together first. Then plus 2 into what? The rest, 0.5 plus 1 plus 1.5. Yeah, that's it. And that's our integral. So it's 4.15 and our answer is B. The range of validity of the binomial expansion of this is, okay, this one is easy peasy. So if I get a plus bx raised to the negative 4, for instance, the range of validity will be what? Just get this bx over a, alright, should be less than 1, that's really it. So in this our case, our bx here will be 3x over 2, should be less than 1, right? So that's it, our answer is A. Thank you guys so much for checking out the video. We hope you liked it. If there are any questions, leave them down in the comment section below. If there are suggestions that you want us to solve, drop them in the comment section. We can't wait to check them out. Thank you so much, guys. Hope to see you soon.